On the green fence. On the green fence.
Today we have all kinds of different bioplastics which are perfectly able to substitute conventional plastics.
We know that bio-based plastics are produced with a high demand of land, so it comes with all the negative impacts of industrial agriculture.
It's very easy for nature to break it down. Typically, our product breaks down in nature in 4 to 6 weeks without any human intervention, no need for industrial composting or anything like that.
In this fourth episode of our series on plastics, I'll be taking a closer look at so-called bioplastics. Are they the silver bullet to our growing plastic pollution problem? I'm Neil King, and this is DW's On the Green Fence podcast. You've probably come across the term bioplastics before. Anything with bio in it has a good ring for environmentally minded people, doesn't it? But as I discovered in this episode, the world of bioplastics has many different shades and grades, and the term bio can be very misleading here. So let's all get on the same page from the beginning and start with a definition of bioplastics. According to the Industry Association European Bioplastics, a plastic material is defined as a bioplastic if it is either bio-based, biodegradable, or features both properties. They are made wholly or in part from renewable biomass, such as sugarcane, corn, or cellulose, just to name a couple of the most common feedstocks. But even if this sounds super green and natural, it's very important to understand here that not all bioplastics are biodegradable. It depends entirely on the chemical structure as to whether something can biodegrade easily. And depending on their design, some bioplastics can have exactly the same chemical structure as their fossil fuel counterparts, mainly because their creators wanted to achieve the same degree of durability, such as bio-based PE or PET. So it's a bit like building a Lego house, according to the very same plan, except that you're using different feedstocks for the Lego bricks. So breaking down these finished Lego houses is equally difficult in both instances, because once you've put them together, they end up being exactly the same polymers with the same properties. This means that some products that claim the bioplastics label can further fuel the very same waste problem we already have with conventional plastics. However, within the family of bioplastics, there are some that are both bio-based and biodegradable, such as PLA and PHA or starch blends. But even here, there are distinctions. So PHA is, for instance, both compostable and biodegradable in marine environments, whereas PLA is compostable in industrial facilities but may stay for up to 1,000 years in the marine environment. So bioplastics really is a very sweeping term for a large family of very different substances with very different properties and environmental impacts. And some of them are already being used for food packaging, agricultural films, composting bags, and other consumer products, for instance.
So today we have all kinds of different bioplastics which are perfectly able to substitute conventional plastics, and they have quite a few properties which make them better than the conventional ones.
That's Hasso von Pogrell, the managing director of the Industry Association European Bioplastics, which is based in Berlin.
The benefits of bioplastics is indeed, since they're bio-based, you don't have to rely on fossil fuels for making them. You're using annually regrown, renewable material, especially coming from agro feedstock or from lignocellulosic feedstock, and these have the great advantage that the carbon footprint is much lower than their conventional counterparts.
However, the results of the bioplastic environmental impacts have a significant range, depending on the differences in yield factors, underlying production processes, and other aspects. So some crops perform better than others, and it also depends on what happens to the bioplastics at their end of life. But according to a 2020 study titled The Unintended Side Effects of Bioplastics, the CO2 emissions to produce petrochemical polymer packaging for Europe are estimated at an average of 56 million tonnes, compared to an average of 15 million tonnes for bioplastic substitution. So, in terms of emissions, they would perform better here. But if bioplastics are such a promising and less carbon-intensive alternative, why do they only make up a fraction of all plastics globally, about 1%?
That's a good question. No, the thing is, bioplastics is still a rather new sector, which needed to be developed by industry. And of course, even though the demand for more sustainable plastics is quite high, there is still, in some cases, a perception that bioplastics might not have the same properties that you're used to with conventional plastics. And this is something that still has to be made commonly known, that they can indeed perfectly well replace conventional plastics in more or less all applications out there.
Mm-hmm. Has it also perhaps got something to do with the price? Are bioplastics more expensive to produce?
Yes, indeed, since the production is certainly in most cases not on the same scale as for conventional plastics, the price of bioplastics in most cases is higher than conventional plastics.
Can you give us an idea, a bracket, just how much more people have to pay if they wanted to, switch to bioplastics?
Somewhere between 2 to 3 times as much.
Okay, so bioplastics come with a much larger price tag than conventional plastics. But this could, of course, change if they are scaled. And judging from the economic stats, it's possible that we're heading that way. In 2022, the global bioplastics market size was estimated at $11 billion and is expected to expand at a compound annual growth rate of 18.8% from 2023 to 2030. Europe dominated the bioplastics market with a share of 43% in 2022. But of the global production capacity of bioplastics, which was 2.42 million metric tons in 2021, Asia accounted for half. And by 2026, Asia's share of bioplastics production capacities is forecast to increase to more than 70%. So why aren't the Europeans themselves producing more of this material if they are dominating the market?
Well, I think since the bioplastics, since they're made of renewable material, you have a lot of crops that you use for making bioplastics more in other countries. So the European resources are used more for biofuels or for food and feed. But in other countries, especially in Asia, you have support for bioplastics. So the production is actually being done in these countries.
But maybe it's also a space issue, which brings me to one of the main points that critics often highlight when it comes to bioplastics. Just how much land is required, and how problematic is using crops for bioplastics instead of feeding people with it. Hasso was pretty unfazed by this.
The land use is not problematic at all. The perception of it is unfortunately different, but the real numbers show that to produce all the bioplastics we're producing today from renewable feedstock, we're talking about 0.016% of global land. So the issue is not at all the land use, it's only the perception that you're using feedstock which otherwise could be used for food or feed.
But that's today. So what happens if bioplastics are in fact scaled in future to replace conventional plastics? Well, according to the NGO Deutsche Umwelthilfe, or Environmental Action Germany, if we wanted to replace the entire global demand for plastics with bioplastics, we would need almost 5% of the world's arable land to do so. That's 75 million hectares of land, which is more than twice the area of Germany. And just to add a bit of context in terms of crops here, globally, around 170 million tons of plastic is used for packaging purposes annually. Substituting these petrochemical plastics with bioplastics would require over 600 million tons of corn, for instance. That's half the current global production of corn, by the way. But even if we were willing to set aside that much land and crops for bioplastics production, there is another problem. All these crops need water. Some estimates suggest this would require some 390 billion cubic meters of water. That's about 60% more than the EU's annual freshwater withdrawal. So this land and water use would explain why we Europeans are happy for the crops for our bioplastics to be grown elsewhere. So it's not all that surprising that environmental groups are critical of scaling bioplastics. Like Janine Korduan, who spoke to me on behalf of the environmental NGO Friends of the Earth Germany.
For us, bio-based plastics are also a really big problem, because especially when bio-based plastics are used to replace single-use plastics, we do see it's a really big problem. We know that bio-based plastics are produced with a high demand of land, so it comes with all the negative impacts of industrial agriculture. We do use a lot of fertilizers, we use pesticides. For this, we need a lot of oil and gas as well. We do need water. When we look now on bio-based plastics in the packaging sector, we know that a lot is produced on the basis of sugarcane. And this comes, for example, from Brazil. It is super problematic with all the aspects that I just mentioned. There's even pesticides used that are not even allowed in Germany. So all of this is very problematic.
But no matter where or how they are produced, the problem remains that not all bioplastics are biodegradable. In fact, only about half of them are, and even those require industrial composting facilities and a certain temperature to degrade properly. Hasso von Pogrell acknowledges this problem, but he also offers a solution.
Well, in the ideal world, the bioplastics, especially the packaging for food waste, would end up in the bio bin, and with the bio waste end up in the composting facility. There, it shouldn't be necessary to sort out the plastic because it biodegrades perfectly well with the bio waste. The problem is only that if you also have conventional plastics entering the bio waste stream, then the composting facility, of course, has an issue, and that's why many of them already today sort out all plastics that are visual, because they want to make sure that no non-compostable plastics end up in their bio-waste stream. This is the difficulty, and this is why we think that you should make specific applications mandatorily biodegradable to be sure that the plastic entering the composting facilities is indeed certified biodegradable.
But it's not just that some composting facilities reject bioplastics because they can't distinguish them from conventional ones. There's also the issue of which chemicals they may contain and the safety of these compounds. According to a study by scientists in Germany and Norway released in 2020, most bioplastics and plant-based materials contained toxic chemicals with similar toxic levels to conventional plastics. But there is another side to this.
Of course, from a polymer to become a plastic, indeed, additives are necessary for all plastics, also for bioplastics. But especially in the case for compostable plastics, they need to pass rigorous ecotoxicity tests, and therefore the allegations that those additives are indeed a problem is not the case. If I may, just an example, in Germany, you will have a lot of composters saying we should collect the compost not in biodegradable waste bags, but for example, in newspaper. The newspaper wouldn't pass the ecotoxicity test that the bioplastic needs to pass to be certified industrially compostable, just to understand how rigorous the test is.
Is that because of the printing inks?
Exactly. And this is something that obviously is misunderstood because everybody thinks paper, especially newspaper, is perfectly biodegradable, which it is, but if you look at the ecotoxicity, then they become a problem.
Let's just leave Hasso von Pogrell from the Industry Association European Bioplastics there for now, and move on to a startup that I think really has the potential to cut through most of the problems we just looked at.
The USPs is that the materials that we use for packaging have been in this environment for hundreds of millions of years, so nature knows exactly what to do with it. Seaweed is very abundant compared to other types of biomass, like using agriculture-based crops. We have something that's not going to compete with food, which is really great compared to the first generation of bioplastics.
That's Pierre Pallier, the co-founder of the UK-based startup Notpla, or Notplastic. His company, which was founded in 2014, says it is producing a non-chemically modified bio-based plastic that is classified as a natural organic substance by EU law, just like fruit peel, except it's not made from fruit, but from seaweed. And it easily biodegrades in nature in just 4 to 6 weeks without the need for industrial composting or special conditions. But before getting deeper into the details of seaweed packaging, I wanted to find out a bit more about Pierre and where the idea came from.
I used to be a packaging engineer. I was working for L'Oreal, the cosmetics company, making lots of kind of like single-use plastics, bottles, jars, all kind of like made of this indestructible material. And when you see them kind of like being produced on those lines, you really realize that like we're really good at making them, but we're not like having any particular plan for dealing with them at end of life. It's kind of crazy. So I quit the job and I came to study a master's here in London called Innovation Design Engineering at Imperial College and the Royal College of Art, where I met my co-founder, Rodrigo. His background is in architecture and design, so nothing to do with seaweed either. But during this master's, one of the projects that kind of like we decided to work on was how can we make man-made fruits? How can we create a container that feels more like something you find in nature than something you find in a factory? And for this, we didn't really have kind of access to special labs. So we started in our kitchen with materials that were coming from the cupboard. And we kind of like stumbled upon the technology used for making fake caviar, the little kind of like fish bowls that you can have like very cheap at Christmas. And that uses an extract from brown seaweed and a salt to create these little bubbles. And the idea was that like with a very tiny bubble, you can just encapsulate something that looks like caviar. But if you actually make it bigger and bigger, maybe you can make packaging. And so that's what we try to do. We try to make the bubbles bigger and bigger. A bubble that contains water or different liquids that you can literally eat because the seaweed is edible. And we found that like that would be a particularly kind of like useful thing to create for marathons, for example, where runners use kind of like hundreds of thousands of those kind of like plastic cups or plastic bottles for just 20 seconds. So we started testing that out with runners and see how it would work. And that was the beginning of our exploration with seaweed.
But using seaweed is a lot more complex than the word lets on. There are over 12,000 different seaweed species to draw from in the ocean. So it's abundantly available in nature, but how is the packaging actually made?
So what we do is that we've learned how to use from different seaweed, different extracts that have the right properties for packaging applications. We blend them together. So we first extract the gelatinous part of the seaweed, and then with that gelatinous part, we can create different formulations. And a lot of work has actually gone into retrofitting this raw material into the existing supply chain of synthetic materials like plastic. So for quite a lot of our products, we are actually running on the same factories, on the same lines, at the same speed as plastic would, so that we don't have to build everything from scratch.
And the raw materials, you said, I mean, they're like over 12,000 species of seaweed. You've pinpointed several that you are using for your product. Just regionally speaking, I mean, where does the seaweed come from?
So actually, like for the past 8 years, we've really kind of like built a lot of relationships. Our ambitions are global, so we want to be able to kind of like provide our products in Australia and South America and Europe and everywhere else. So the goal is that we can create and stimulate the industry, which is kind of like existing but still nascent, to really create some of that capacity to transform the seaweed locally. So today we have kind of like tested in our lab seaweed from probably like 50 different parts of the world, different species.
And there are not any adverse impacts on biodiversity if you take seaweed out of the ocean, or is that a problem that you're looking at?
Yeah, so quite the opposite. Like one of the amazing thing about seaweed is that it's regenerative. So actually, like the model that we really prone for seaweed is aquaculture, where you're essentially kind of like farming seaweed in the ocean. The incredible thing is that like seaweed is actually the first kind of like step to rewild a portion of the ocean that has very little life. It provides the food and the shelter to the kind of like fish nurseries. And actually, like the fish, they take their share. So they'll kind of like eat 25% of the seaweed. Another kind of like 25% will be kind of like taken off by the currents, and that will sequester carbon to the bottom of the ocean for hundreds of thousands of years. And then what's left can be used for substituting plastic, for example. So we really think that it's a model that has kind of like a lot of virtues. And by the nature of the ocean, we can't really recreate the mistakes we've done with agriculture on land, because you can't use fertilizers, you don't need fresh water, so it's really a zero input crop to grow. You can't kind of like control it the way we've kind of like done with intensive agriculture on land. So,
and what about the conversion rate? If we were just to sort of, as an example, I'm trying to picture maybe a 1 liter plastic bottle. If you were to make that with Notpla from seaweed, how much seaweed would you need for that?
Yeah. So we don't do bottles yet, but certainly we do kind of like for example, takeaway boxes where we like apply a thin layer of seaweed onto the cardboard to make it resistant to the food and the grease, because typically that's done with a thin layer of plastic. And for a box, yeah, we need kind of like a couple of grams of seaweed. We've actually calculated that like with one of our partners in France, if we were to use kind of like all the manufacturing capacity they have today in their kind of like plant, which uses the seaweed from the 20-30 kilometers radius around where they are on the coastline, we could make 1 billion boxes. So that's just kind of like the scale of the resource. So the potential is really enormous. Another kind of like fun fact, but we don't anticipate seaweed replacing all of plastic. That's not doable with the properties that it has. But it certainly can kind of like replace a lot of kind of like plastic for quick consumption cycles. But if just for math's sake, we were calculating how much of the ocean we would need to cultivate to be able to replace the entire weight of plastic used for single-use plastics in the world, we would need to cultivate 0.06% of the ocean. So that's just kind of like how much potential there is for seaweed to play a role in replacing like some of those single-use plastics. We think that like seaweed is going to be playing a major role in things that are used quite quickly and don't necessarily have the need to be very sturdy or resistant. We're probably not going to do reusable kind of like containers with seaweed, because the main property is that it's very easy for nature to break it down. Typically, our product breaks down in nature in 4 to 6 weeks without any human intervention, no need for industrial composting or anything like that. So that's very fast, but it also means that it's a compromise on the durability of the material.
So that also means, I mean, all the ingredients in your packaging, it's all natural. There are no chemical additives or anything like that.
Correct. And actually, that's one of the things that is sometimes hard to kind of like to understand in the market, is that there's a lot of bio-sourced or kind of like bio-based materials that are claiming to come from plants, but actually like they really are deconstructed and rebuilt into a new material that is plastic. So for example, the main bioplastic is PLA, polylactic acid. It's actually not very compostable because it requires industrial kind of like facilities. So if you leave it in the environment, it's going to create the same slow fragmentation into microplastics than your regular kind of like petroleum-derived plastic bottle. It's also something that has been used for greenwashing a lot, the space. What is plastic-free? Luckily, the European Union has started to be a little bit more firm on that front and has introduced a definition of what is and isn't plastic. So basically, like anything that is polymerized artificially or chemically modified from a natural resource is a plastic. So if you take something that is abundant in nature, but you then kind of like chemically modify its structure, that's a plastic. Or if you take an abundant material and you polymerize a new polymer out of this that hasn't been polymerized in nature, that's also a plastic. So it means that like PLA and PHA, the two main bioplastics, are firmly in the category of plastics. And at Notpla, it's a bit in the name, Notpla, not plastic. We are really kind of like excited about the role that native polymers, the polymers that have been around the environment for millions of years, have to play to help us reduce our addiction to plastic.
How big is the demand for your products? Is there, I mean, where do you see the biggest growth potential, also maybe in terms of regions and specific products? Is your phone ringing non-stop?
Yeah, so I think it's a really interesting moment because the value proposition is incredibly kind of like attractive for lots of brands. They're really keen to kind of like get their product more sustainable because their clients are asking that. And however, like any innovative product, we don't come at the level of kind of like optimization of plastic. So there's still a premium cost attached to that kind of like ramp up that we need to do because there is still a lot of optimization that we will be doing in the next coming years. And the other thing is as well that like plastic doesn't take into account in its price the externalities. So the cost of pollution, the cost on marine health, the cost on human health, none of that goes into the very low price on the market of plastic. The real cost of plastic, as studied by various big consultancies, is at least 10 times the retail price of plastic. So it's not a cheap material. It's just that like we're able to buy it today at like a 10% deposit, and we leave the rest of the mortgage to pay for future generations.
Pierre, as you mentioned, virgin plastic produced from fossil fuels it's dirt cheap. I mean, it's even cheaper than recycled plastic, right? So it's just a crazy setup, and it's making it really hard to get off this plastic drip. You also, as I understand, have a competitive disadvantage there because the externalities that you mentioned, they're not included in the price for fossil fuel plastics, all the environmental pollution, etc., all the costs attached to it. The other aspect you mentioned, the durability, the fact that, which is an advantage in your case, that it degrades in nature very fast. It's super compostable. It's just like throwing away fruit, basically. But that's also a downside for some plastic packaging products, I would imagine, where durability or shelf life is important. Aside from these two factors, what would you say, are there any other aspects or any other obstacles that you face when you are trying to sort of, take away some market share from conventional plastic producers? What are the other obstacles that you have to overcome?
Yeah, there's one more that is kind of like actually quite big. It's really greenwashing. The level of confusion around materials in packaging is really creating a lot of friction for the better solutions to reach the full potential that they have. And there's a very cynical kind of like approach to the whole question of materials in packaging. We've seen some horrendous kind of like rebranding of hidden plastics into plastic-free, biodegradable, recyclable solutions, when actually it's just the same old plastic, but in a different format. All of these things have largely gone kind of like unchecked because there is still not a very strong enforcement of the greenwashing claims kind of like checks. But things are changing. And I think that in the UK, you've got the green claim codes. In EU, you have like the green claim directives that are going to make it a lot more dangerous for brands to keep on squishing as much as the messaging out of little initiatives that they're taking. I think that the fines are starting to be quite significant. I think it's up to 10% of like global turnover for significant greenwashing claims. So that is a big deterrent. And hopefully that's going to stop some of those untruthful solutions. But that takes away a lot of the potential buying power that those brands have towards the true next level kind of like materials. So we're just seeing like some plastic going from the visible plastic to the hidden plastic. And I think that that's certainly something that we're concerned. In our takeaway boxes, there's one thing called aqueous coatings, which is basically a microplastic coating that evades a bit the definition of plastic as of today, but it's still polystyrene, polyacrylate, kind of like microplastics. It's even worse for the environment because it's sold as recyclable, but the moment you recycle the fibers, all of that microplastic gets into the river, the ocean, so it's basically fast track to microplastics. But that's sold as plastic-free in a number of different kind of like European countries. So we need a little bit more bite, I think, from regulation to make sure that like people who have the willingness to buy something that is more eco are not being fooled easily or willingly by the solutions on the market.
Pierre, final question. What's the next move for Notpla? What's the outlook, future plans? Where is this going?
We're actually fundraising for the next phase of growth. We're also kind of like really looking at some of those new products that are being developed, this kind of like rigid injection moldable material that would open quite a lot of applications, from cutlery to hangers to boxes to all sorts of different kind of like molded materials opportunities. We are mainly active in Europe now, but I think that like our eyes are very much on how we can open new geographies. There's lots of demand from the US, so we are very conscious of like the opportunity there. But I think that like the goal is going to be like, seeing how we bring those products that have already worked, like after like about 3 million single-use plastics replaced in Europe in the last 18 months. How can we start doing some of that work in other geographies? That's what on our mind.
Many thanks to Pierre Pallier, the co-founder of the UK-based startup Notpla. Personally, I found Pierre's seaweed packaging concept very convincing, especially compared to those bioplastics that require a lot of agricultural land, water and pesticides. Durability and pricing sounded like the main stumbling blocks to me for now, but even if there are promising alternative materials to get us off the plastic drip, environmentalists like Janine Korduan from Friends of the Earth say that the whole debate around substitution of plastics is in fact distracting us from what really needs to change.
So when we look at paper, when we look at aluminium, bioplastics, all of this is bad when we use it just for a short amount of time as a single use, because we have a lot of trade-offs when we produce single-use paper. For example, we use a lot of pulp, and for this we do need trees or eucalyptus and other resources from Brazil. This is absolutely not sustainable in any way. By the way, they are often coated with PFAS, so like long-lasting forever chemicals. When we produce aluminium, we contribute to climate change immensely because there are climate-potent byproducts like CF4. We have a lot of bauxite that needs to be mined. There's a lot of environmental damage with the aluminium production. And that's why reuse and long-lasting products are the key in all the sectors.
And that clip from Janine is the perfect segue to our final episode of our plastic series, which is going to be about recycling. Janine will be playing a prominent role there, and so will this man, who created a rather unique recycling startup after experiencing a bit of a Damascene moment while on holiday.
We literally got stuck in a massive carpet of algae and plastic waste. And this was the moment where I asked myself, what on earth are we doing? I came back to Germany. With this thought on my mind, let's do something about plastic waste, the most underused resource of this planet, I would say.
I really hope you'll be joining us again for that. That's it for now. If you have any questions or feedback, please send us an email or a voice message to onthegreenfence@dw.com. You can also interact with us on Spotify. Many thanks to my colleague and producer Natalie Muller and my sound engineer Gerd Georgi. And a big thank you to all our listeners for sharing and reviewing On the Green Fence. My name is Neil King. Take it easy and take care.
On the Green Fence.